Today, we will discuss some of the concepts related to electricity, resistors in series and parallel combination. So, resistors, resistors in series and parallel combination. Resistors series combination means it will come like this. They will be connected end to end like this. Suppose this is R1 resistor, this is R2 resistor. This is called series combination. In this series combination, the equivalent resistance of these two resistors will add up. That means R equivalent resistance R is equal to R1 plus R2. Parallel combination means both the ends. This is R1, this is R2. The end of one and the end of two, here also end. If this end, both ends are connected, this is called parallel combination R1, R2. This is parallel combination. This is series combination. In parallel combination, the equivalent resistance is equal to 1 by R is equal to 1 by R1 plus 1 by R2. Generally, formula they will tell like this. So you make R1 and R2 LCM R1 R2. Here R1 is there, therefore here R2 plus R1 is equal to 1 by R. As it is reciprocal, you make R is equal to R1 R2 by R1 plus R is equal to R1 R2 by R1 plus R2. This is the equivalent resistance for a parallel combination. Suppose if it is series combination, it is very simple. R equal is equal to R1 plus R2. If it is parallel combination, it is R1 plus R2, R1 R2 by R1 plus R2. Now one more thing we have to remember, that is in parallel combination, suppose this is the parallel combination. What will happen in parallel combination and what will happen in series combination, that also we have to see. Suppose some potential difference V is applied here. With respect to this applied potential difference, this is R1, R2. The equivalent resistance R equivalent is there. That means this is R equivalent for this circuit. If I am replacing this R1 and R2 by R equivalent value already we told R1 R2 by R1 plus R2. This is V. Then I current will be flowing through this circuit. This current I will be flowing through this circuit depending upon the Ohm's law. V is equal to IR. Here R is nothing but R equivalent. R equivalent is R1 R2 combination. What is the equivalent we are getting? R1 R2 by R1 plus R2. According to Ohm's law, V is equal to IR. Satisfy this condition and that much I will flowing through this circuit. But this I, when entering at this point, will divide into two parts, I1, I2. That means I1 plus I2 will give total I. In parallel combination, same current I will flow up to this point. At this point, this will divide it into two parts. Some part I1 will flow in this part, I2 will flow in this part. Then what happens to I1? How much is the I1? I1 is given by total current. If suppose it is I, then I1 is given by R2 by R1 plus R2 into I is the I1. When you are considering I1, we have to take R2 in the numerator. Please remember. I1, we have to take R2 in the numerator. R2 by R1 plus R2 into I. Suppose if you want I2, then I2 is equal to I2 we want, then we have to take R1 in the numerator. R1 by R1 plus R2 into I. the same current I is divided into I1 and I2. That is nothing but I is equal to I1 plus I2. We can write I is equal to I1 plus I2. In the parallel combination, current will divide it into two parts. Suppose in the series combination, suppose if you consider a series combination, applied potential difference V, here also I current will flow. Here V1 is the potential drop between these 2 points. This is R1 resistance, this is R2 resistance. Here V2 is the potential drop between these 2 points. In this case, series combination, what happens? Total potential V is equal to V1 plus V2. Like in parallel combination, I is equal to I1 plus I2. In series combination, V will become V1 plus V2. Whereas V1 is equal to IR1 plus V2 means IR2. That means in series combination, same current will flow through the circuit. In parallel combination, the current will divide. Only voltage will be same. Same voltage V will appear here, V will appear here. Only difference is that for parallel and series combinations, parallel combination voltage is same throughout the network or throughout the circuit. In series combination, current will be same current will flow through the circuit. So in next videos we will solve one or two problems, it will be cleared.